Hi, Algebra 1. Today we're going to look at section 1.2. It's our second lesson of the year. This is actually split up into two different lessons. Today we're going to look at solving equations and inequalities. And there's a lot going on with these. You can see our objectives there. You can read over those. There is going to be a difference when you end up multiplying and dividing by negative numbers. Something interesting happens to inequalities when that happens, so we'll look at that. And we're also going to do some word problems. It turns out a lot of things in real life aren't equations, they're actually inequalities, because you don't have to be exact. So anyway, let's begin with example 1. Solve and graph each of the following. So for our first example here, we're going to solve x minus 3 equals 5. To solve equations, you often are going to use inverse operations and properties of equality. So what I mean by inverse operations is we need to get x by itself. Well, what undoes subtracting 3? Well, adding 3 undoes it. And then we got to use a property of equality. If we're going to add 3 on one side to keep the equation balanced, we got to add 3 on the other side. And so then our result is going to be nice and balanced and accurate. And x equals 8, excuse me. So to graph that, typically we don't graph equations very often because graphing really doesn't illustrate the solution any better than just saying x equals 8. But I do want to talk about how to graph equations. So what I'm looking to see is I'm looking to see the number we're interested about. And I'm interested in seeing a number behind it and a number in front of it so that we clearly know how a number line works. From there, we want to graph x equals 8. So we just put a big fat dot at 8. And that's all there is to it. So I typically won't make you graph equations because this doesn't really tell us anything more than that. But I will be looking for and counting graphs for inequalities. So let's take a look at an inequality here. So we solve them the same way as equations. We're going to think about inverse operations and properties of equality. So to get m by itself, well, m's being added with the 1/2, so I'm going to subtract the 1/2 to get m by itself. The subtraction property of equality, I got to do it on the other side. And I wouldn't grab a calculator for this. If we have -8 and we subtract 1/2, we're going to be at -8 1/2. And that inequality symbol, you can read it from left to right, but I always read these things from the variable's perspective. And since it's opening up towards the m, I'm going to say m is greater than -8 1/2. And then to graph that, since it's in between two integers, I'm going to go ahead and start there. It's in between -9 and -8. Notice the order on that. The -9 should be on the left and the -8 should be on the right. And then -8 1/2 is going to be right in the middle. Now notice it's not saying that m is equal to, it's saying m is greater than. So we don't use a dot, instead we use a circle. And if you want to go ahead and put a little tick mark there and write -8 1/2, I don't mind. Sometimes you'll see it because it's not an integer, they'll put it up top. But yeah, we can put the -8 1/2 in the middle. And then we have to illustrate where the solutions are. And since it's m is greater than -8 1/2, the number line gets bigger to the right. Some classes like to do arrows. You can totally do an arrow. I've done that for a few years, but I've reverted back to shading for whatever reason. I don't know, but I'll accept arrows as well. So again, you are going to be responsible for graphing inequalities because the graph, I feel, it helps you understand the relationship better. Going on to C, part C, I'm going to work this as a one-step equation. I'm going to undo the 5 by multiplying by a 5. Property of equality says I got to do it on both sides. I'm going to undo the negative by, oddly enough, multiplying by a negative. Now you might be thinking, well, that doesn't seem like the opposite, the inverse operation, but it is, because what happens is a negative times a negative makes a positive. The 5s are going to divide out. So we're left with n, and then we multiply here is equal to positive 15. And I'm not going to bother graphing it because it's an equation. It really doesn't help us any to graph it, I don't think, other than exercising our knowledge of a number line. Okay, example D. I'm going to undo dividing by 8 by multiplying by 8. And because it's an inequality, I'm going to graph it. And we got a nice number, so we'll put 40 in the middle. To the right will be 41, to the left 39. A circle or a dot? Well, it's not equal to, so it's going to be a circle. And since it's greater than, we'll shade to the right, like so. For our next example, we're going to be getting x by itself, so we'll divide by 3. Inverse operation of multiplying by 3 is division, but then we got to do our property of equality. We got to keep it balanced. So we'll have negative 8 is greater than or equal to x, but I prefer to read it from x's perspective. X is less than or equal to negative 8. And because it's an inequality, we'll graph it. So to the left of negative 8, it's going to get biggerly, a more significant negative. So it's going to be negative 9. To the right, negative, losing some lead here. Let's see. Negative 7. And in this case, we can be equal to negative 8. So we're going to put a dot. And since it says less than or equal to, we'll shade to the left. Okay, so we got quite a bit of things going on here. So take a moment, pause the video if you need to, and think about what this all means. All right, so here's where it gets a little more interesting. It says, when multiplying or dividing both sides of an inequality by a negative number, you must flip the inequality sign. Now, I don't remember this being explained to me very well when I was taking Algebra 1, so I want to take a moment to explain why this happens, okay? And I think a good way to illustrate it is if you look at something like this. You write a 1 and a 3, and you ask yourself, well, what's the relationship between 1 and 3? Well, 1, I'm having pencil issues. 1 is less than 3. But if I was to multiply or divide both of those numbers by a negative, I would end up with a negative 1 and a negative 3. Well, now if you think about the relationship there, you'll quickly realize, wait a second, negative 1 would be on the right of negative 3. So that means negative 1 is greater than negative 3. And this illustrates why you have to flip the sign, because the whole inequality relationship changes. It flips around when you multiply or divide both sides of the inequality by a negative sign. So that's kind of the why behind it. Now let's put this into action. To undo this negative 7, that's multiplying, we will divide by a negative 7, divide by a negative 7. And because I'm dividing both sides by a negative, I'm also going to flip the sign. And because it's an inequality, we'll graph it. Like so. Moving along. Undo dividing by a negative 3 by multiplying by a negative 3. And because we multiplied both sides of the equation by an inequality, the inequality sign flips. And we're reading that solution as y is greater than or equal to negative 6. So negative 6, negative 7, negative 5, dot, and greater than. Okay. Coming up, you may look at this and say, all right, I know what to do here. I'm going to divide by 1/10. Well, yeah, technically that's correct. You can divide by 1/10. And as long as you're careful with your calculator, it will give you the right answer. But what I would like for you to realize as well is that reciprocals are multiplicative inverses of multiplication. They're the inverse of multiplication. So what I'm going to do when I see a fraction like this multiplying is I'm going to think of the reciprocal. And there's multiplicative inverses. You flip it upside down. So I'm going to multiply by 10 on both sides of the equation or inequality. And 1/10 of 10 is just 1. So I'm just going to cross those out because it's just going to be a z here. Now notice, am I multiplying both sides of the equation by a negative? Not at all. I'm multiplying by 10 on both sides. The inequality symbol is not going to flip here. And we're ready to graph. Circle less than. Okay, so if you need to, pause the video for a second and think about what we've got here. See if it makes sense. On the back, we're going to do some word problems, and we've got these steps here to help us out. And yeah, figure out what you know and what you need to know. Basically, what you need to know is typically your variable. So it says to define a variable for what you need to know. Often I'll use a variable that has the same letter as the first letter of what I'm trying to find out. That way it kind of makes sense. From there, write an equation or an inequality and solve it. So they're kind of have this box around it, I think, to say kind of this is the new stuff. And then once you've got the equation or inequality written, it's the old stuff. So we've got an example here. It says you earn $9.50 per hour at your summer job. Write and solve an inequality that represents the number of hours you need to work to buy a digital camera that costs $247. So we know that you earn $9.50 per hour. You know you want to get a camera that costs $247. What are we trying to find out? Write and solve. Okay, write and solve. Okay, so we're trying to find out the number of hours, right? We're trying to find out the number of hours you need to work to get the camera. So since it's hours that we're looking for, I'm going to assign that variable as h. And I think I've got an idea of how this works. There's a few different equations or inequalities you could write here, but the way I'm seeing it is I'm going to make $9.50 per hour for every hour. So how much money I get is going to depend on how many hours I work. So I'm going to multiply the $9.50 by how many hours I work, and I need that to be equal to 247. But here's where I got to pause for a moment and think this through a little bit clearer. Would it be okay if I work a number of hours that actually puts me over 247? Would that be okay? That would totally be okay, right? And chances are with the $9.50 per hour, I may not come out exactly at a whole number of hours. It may be like a fraction number of hours or something like that. So I'm going to go ahead and change this. I need to have at least 247. So I'm going to say greater than or equal to 247. I'm going to be happy with all of that. So to solve this, we'll divide by the 9.5. And it turns out it does end up being a nice integer there. We need to work at least 26 hours. 26 hours will get us there. If we happen to work a longer shift, no big deal. So the number of hours is going to be greater than or equal to 26. All right, part B here. Let's take a look at example B. In 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Okay, so speed and velocity are essentially the same thing. So if you're not sure, if you haven't had some science classes, Velocity is equal to like distance over time. That's a formula that I'm going to use here because I know the distance, 200 meters. I know the time, and it says we're trying to find his average speed or velocity. So speed or velocity is what we're trying to find. Well, I think I'm ready to write an equation here because I know that velocity is equal, or speed is equal to distance over time. I'm ready to fill in what I know. I'm going to call, we'll call the average speed, we'll call it S. I'll be honest, I like to avoid S a lot of times because my S's look like 5s, but I'm sure you draw your S's a lot better, and I tried really hard right there. So we'll go speed is equal to distance over time. And a little secret I'll let you in on is in the math department over at Willard High School here. If a problem starts with decimals, you can have decimal answers. If it doesn't start with decimals, we prefer fraction answers. So we're going to be okay with decimal answers here. And when you divide these, you're going to get that the speed is 10.35, and it keeps going. It goes 1966, but they wanted us to round our answer, and that's, by the way, meters per second. Meters per second is the units on this. I think that's kind of a good thing to keep in mind. And it says meters per second. They want it rounded to the nearest hundredths, tenths, hundredths. So there's the hundredth spot. And then to round, we look to the right. And if it's 5 or more, we round up to 6. If it's 4 or less, we leave it as it is. So since they want us to round there, our answer is 10.35 meters per second. And there you have it. Thanks for watching.